Hey everybody, Mr. Simone again. Today's video is just a secondary video for graphing lines using point slope form. So anytime you're given point slope form from previous videos, you'll know that what's so special about point slope form? Well, it was a formula that was, or a function that was derived from the actual slope formula, your change in y over change in x. And specifically, point slope form gives you a slope, and it also gives you a particular point that you know works for the equation or for the function. You graph the point, and then you can graph the rest of the points using your slope. In this video, we're going to look specifically at how we can kind of convert our slope-intercept form into, our point slope form into slope-intercept form. So in other words, how to convert this into something that looks like y equals mx plus b. Okay. We are kind of comfortable with that y equals mx plus b form, where m is your slope and b is your y-intercept. This was the first kind of linear equation or linear function that we've looked at that we were all really comfortable with. So what we're going to do is we're going to dive in. I'm going to show you some of the steps that you can take to convert from point slope to slope-intercept. The very first thing you want to do is you're going to want to distribute, and you'll see that here. So step one is to distribute your slope. So you're going to get y minus 2 is equal to 3x minus 1. All right? Oop, don't forget to do the doop-de-doop. You got to distribute the quantity of 3 times x and 3 times that negative 1. All right, and the second step, it says isolate y by getting rid of the attached value. So what's attached to y is that minus 2, and we're going to add 2 to both sides of our equation. Remember, when you add 2, the 2 must go with that constant quantity because they are like terms. So what you end up with is you end up with y by itself is equal to, you've got your 3x minus 1. Why is that so special? Well, it tells us specifically that our slope is that 3 value, or we can represent that as positive 3 over positive 1. All right, and our b is negative 1. What does that mean? Well, we can plot negative 1 on the y-axis because that's considered our y-intercept. And then we're going to use the slope to plot all other points. So up 3, 1, 2, 3 over 1. Up 3, 1, 2, 3 over 1. And vice versa, we can also go in the negative direction. So instead of going up 3, we can go down 3, 1, 2, 3, and to the left 1. Once we've exhausted that, we can draw in our line, connecting our points with arrows on the ends. Okay? If you look at our original equation, you'll notice that you do have a slope, and the particular point you would use, or the point that's given in the point slope form, in other words, the point that works, is the point 1, 2. You'll notice that the point 1, 2, our particular point, is actually on the graph. But there are instances where you go to graph in point slope form, and that particular point is off the graph. Well, one solution is to convert your point slope form into slope-intercept. All right, so let's do a couple more examples. We'll look at kind of different things, but the same process. So here's point slope form. We're going to distribute. Step one is to distribute our slope. You're going to end up with y minus 2 is equal to 1/4 x plus 1/4 times 4 is 1. We're going to isolate the y by adding 2 to both sides. Remember, the 2 is a constant. It needs to go with like terms. We're going to end up with y equals 1/4 x plus 3. Slope is 1/4. Change in y over change in x. And my b, my y-intercept in this problem, is going to be 3. So I'm going to plot my y-intercept, which is 3, and then use the slope to plot all other points. Up 1 to the right 4, and I can go down 1 to the left 4. I've exhausted all points that I can plot, connected together, arrows on the end. And then our last example, if I distribute the negative 2, same idea, you're going to get y plus 5 is equal to negative 2x minus 2. Okay, negative 2 times 1 is that negative 2. We're going to isolate y, subtract by 5 on both sides, and you end up with y equals negative 2x minus 7. Slope is negative 2, which is the same thing as saying going down 2 and to the right 1. And my b is equal to negative 7. Now you'll notice on this graph that if I try to graph my y-intercept of negative 7, it's off the graph. Alright, that's not a big issue, but what you can do is if that does happen, maybe you want to go back and find out what your particular point is. What's the point that works for point-slope form? In this problem, our particular point is going to be a point that zeroes out x and zeroes out y. So to make x equal to, or to zero out the x term, we know the x value is negative 1. To zero out our y term, we know that the y must be negative 5. So even though our y-intercept, when we convert to slope-intercept, is off the graph, you can always rely on what you know about point-slope form, which says that our particular point is negative 1, negative 5. All right. Our slope of negative 2 over 1 does mean that from our y-intercept we would go down 2 and to the right 1, but you can also do the opposite. You can also say, instead of going down 2, I can go up 2, and I can go left 1. Which kind of shows us that, yeah, if I go backwards and I go up 2, I can go to the left 1, and I still will be on that line. And we can continue that pattern. Up 2 to left 1, up 2 to left 1, and continue it until you can't continue it anymore. Connect all of our points with a straight line, arrows on the end. So you'll notice that in some cases, your points, depending on how the equation looks, you can use either form to help you. But this video, the idea is that if you are dealing with a linear function, no matter if it's point slope, slope-intercept, or standard form, they're all interchangeable. And for this, you can change point slope into slope-intercept. Or sometimes you may need to rely on the fact that even if you convert to slope-intercept, you may still need to use point slope to help you with the problem. All right, I hope this video helps, and continue to watch.